Today we are going to be talking about attributes of cubic and quartic functions. Some of the things we're going to talk about is the degree, the name, is it odd or even, leading coefficient, and end behavior. So cubic is part of TEKS 2A.2A, and quartic we're going to teach as an extension of that TEKS. So first of all, we have three important things, and really these first two are going to be the most important. So a polynomial function is a function in this form, and I know it looks like it has a lot of letters, but a sub n is just your leading coefficient, and your highest degree is your n. Okay, so if they're out of order, we put them in order because a polynomial function is in standard form when its terms are written in descending order of exponents from left to right. That means we're going to put our highest exponent first. And so our highest exponent is our degree. And the coefficient that's in front of the x with the highest exponent, that's going to be our leading coefficient. This is going to help us decide what the graph is going to look like. And there's some main ones that we use a lot. So today we are going to focus on cubic and quartic. Algebra 1, you did constant, linear, and quadratic. So quadratic has an x squared. Cubic is going to have an x cubed. And quartic is going to have an x to the fourth power. So when you put it in standard form from highest exponent to lowest exponent, the fourth power would be quartic and a third would be cubic. So now we're going to look at naming these. So what's the degree? My degree is going to be my highest exponent. So my highest exponent on this first one is going to be 3. Well, is it odd or even? This is odd. This is going to be important for the next section we're going to do. If it's a 3, this is a cubic. And the leading coefficient is a 1. Okay? Which it's a positive number. We're going to want to know that. Okay? So for our second problem, our degree is 4. 4 is an even number. If it's a fourth degree, the type is quartic. And this is my leading coefficient. Nothing else matters except for my highest exponent term. Okay. For the next problem, okay, is this in order? Yes, this is in standard form. So my highest exponent is a 4. So this is the fourth degree. 4 is even. If it's a fourth degree, the type is going to be quartic. And what is my leading coefficient? It's a 2. And if you want, you can pause this video right here and try doing the very last question on your own. Okay, it was the third degree because my highest exponent was 3. 3 is an odd number. It's a cubic. And my leading coefficient in the front is a -2, and I want us to know that it's a negative number. You're going to see why this is important. So a big part of attributes is the end behavior. What is end behavior? End behavior is knowing where my arrows are going to go. Knowing if the arrows are going to positive infinity or negative infinity. So you know how we were saying even and odd? Well, if the degree is even, they both will face up if it's positive, or they both will face down when it's negative. Okay, again, if the degree is even, second power, fourth power, sixth power, the arrows will face in the same direction. If your exponent is odd, okay, one will face up, one will face down. If the leading coefficient is positive, we start with the negative, and then this is positive, and vice versa. So here are some examples that you can look at, but now let's put that into practice. You're going to want to copy this graph down, and you're going to want to copy the end behaviors. So right here is the end behaviors, and we read this, f of x, which is my graph, is approaching negative infinity, because it's going down forever, as x approaches negative infinity. So your left side is always going to be as x approaches negative infinity, and your right side is always going to be as x approaches positive infinity. What's going to change is the first line every time. Okay? Where are the arrows going? So now let's try to do a couple practice questions. So here is, we're going to practice a couple times, and again, in behavior is going to be our main goal here. So for this first one, the degree, it's a 4th degree, which is even. Okay? My leading coefficient is the number in front of my 4th degree, that's 5. It's positive. So we're going to look at the table. When is my degree even? So not these two, it's one of these. And my leading coefficient is positive. So this dashed means it doesn't matter where this dashed is. All we need to know is that somewhere in my graph, all I care about is these arrows. So the graph has 2 endpoints that are going up to infinity. So in behavior, we have the left side and the right side. So on the left side, and this is basically what we're going to write. Okay, we're going to write these two things. We're going to write f of x, that's the graph, is going to approach a positive infinity when x is approaching a negative infinity. Because on the left side, x is always negative infinity. On the right side, x is always positive infinity. But what's happening to the graph on this side? F of x is also approaching a positive infinity. Okay, so we have 2 end behaviors. What's happening to the arrows? So our last question, let's look at this. Our degree is our highest exponent. So our degree in this problem is odd, which means our arrows, our endpoints, one's going to be going up, one's going to be going down. Our leading coefficient is -2. It's a negative number. So we're going to look for degree, odd, and my leading coefficient is going to be negative, which means the graph is going to go somewhere like this. Again, this graph is not drawn to scale. All we care about is where are my endpoints going. So I have 2 endpoints. Remember, on the left one, x is always approaching negative infinity. So on the left one, what's happening to my f of x? What's happening to my graph? F of x is approaching positive infinity. Let's look at this side over here. What's happening to my graph? The graph, which is f of x, is approaching negative infinity because it's going down forever. But x is approaching positive infinity. So that is how we write end behavior.